Hello everyone, I am Revati, working as an assistant professor in the Department of Information Technology from SNS College of Technology. In my today lecture series, we are going to see about an interesting topic on data structure, which is an Knapsack problem. Before moving on to the topic, we have to know about the today's agendas and a recap of the previous lecture series. Uh, let's move on to the agenda. This is the today's lecture series agenda. Just recap of the previous lecture series, then the problem statement of today's knapsack problem, empathize and define phase of knapsack problem, and the formal definition of the knapsack, and real world applications of knapsack problem. Next, imagine that you have a bag. This bag has a limited space for storing many things. That means n number of items. You also have many items with you. Some items are heavy, some items are lightweighted, and some items are most important than the others. You can't carry all the items within your bag which is you are having. Then so you must choose only a few items in such a way that the total value is maximum, but the bag capacity is not exceeded than the weight value of the chosen item. This situation is called knapsack problem. The recap of the previous lecture series is we have seen about binary search tree, AVL trees, and binary trees. In this video, we are going to see about an knapsack problem. Let's start with the example of knapsack problem. First, consider a Maya Singh. Maya Singh is working as a data scientist in a retail logistics company. Her job is to load promotional items into a delivery truck. This truck is having limited weight capacity. Then each item has weight with its profit value, and then but the truck capacity is not crossed than the maximum capacity. This is the exactly knapsack problem, where the knapsack problem is applied in the real world application. Let's understand with the pain points of Moya Singh. There are many items to choose from the given items. The capacity of the truck is so limited. If Maya choose the wrong item, profit will be less. If she check all possible combinations, it will take a lot of time. So she needs a fast and smart method to make the decision efficiently. This problem is how to clear. And then we have to define the ideas for the Moya Singh problems. We need to select in a way that gives maximum profit without crossing the limit. At the same time, the solution should be the efficient one. To solve this problem, we use a technique called branch and bound. Actually, the branch and bound is an intelligent method. In this method, the problem is divided into smaller parts called branches. Each branch represents a decision to take or not take an item. For every branch, we calculate the best possible profit. If a branch cannot give better profit than the current best solution, the branch is not explored furthermore. This helps in saving a lot of time for Maya Singh. Now let us talk about the 0 bar 1 knapsack problem. In this problem, each item can either be selected or not selected. If the item selected means it will be denoted as 1, then the item is not selected means the value will be 0. Using the branch and bound method, we try to find out the possible choices and calculate upper bound profit for each and every node. The unnecessary parts are ignored and only useful parts are explored. This helps us to find Maya Singh best solution. Let us think about a simple activity for the today lecture video. Imagine each student in the class in an item with a weight and a value. The bag has a fixed capacity. The students decide which item should be kept in the bag to get maximum value. This activity helps in understanding the decision making process easily in the knapsack problem. The knapsack problem is used in many real life applications like budget allocation, logistics optimization, computing, or resource management. Uh, Thank you for watching. Keep on watching my videos on YouTube. Thank you.